Hello students, welcome back to Anita-EduEat. In today's class, we will discuss short answer type questions from the chapter Polynomial, one of the most scoring topics in class 10 maths board exam. Before we start, we will look at some important formulas. For any quadratic polynomial, p of x is equal to ax square plus bx plus c if the zeros are alpha and beta. So, the sum of the zeros is equal to minus b upon a. Product of zeros is equal to c upon a. And to find the polynomials, you can use the formula p of x is equal to k x square minus alpha plus beta into x plus alpha into beta. We usually use k is equal to 1 unless we need to clear fractions. Let's see question number 1. So the question number 1 is for p of x is equal to 2x square minus 3x plus 5. Find the sum and product of zeros and verify the relationship. Given polynomial p of x is equal to 2x square minus 3x plus 5. First, let's identify our coefficients. So here a is equal to 2, b is equal to minus 3 and c is equal to 5. According to the formula, sum of zeros is equal to minus b upon a. Put the value of minus b and a. So therefore, alpha plus beta is equal to 3 upon 2. Again, according to the formula, product of the zeros, alpha into beta is equal to c upon a. Put the value of c and a. So therefore, alpha into beta is equal to 5 upon 2. Question number 2. Find the quadratic polynomial whose zeros are 2 and minus 3. The two zeros, let's call them alpha and beta. To build the polynomial, we need two things, the sum and the product of these zeros. First, find the sum. Sum of zeros is equal to alpha plus beta. Put the value of alpha and beta. So we get alpha plus beta is equal to minus 1. Second, find the product. Product of zeros is equal to alpha into beta. Put the value of alpha and beta. So it's equal to minus 6. Third, build the polynomial. Using this formula, p of x is equal to k x square minus alpha plus beta into x plus alpha into beta equal sign x square. Put the value of alpha plus beta, which is minus 1. Put the value of alpha into beta, which is minus 6. So that p of x is equal to x square plus x minus 6. Therefore, the required polynomial is x square plus x minus 6. Question number 3. For p of x is equal to x square plus px plus q, zeros are twice and thrice of each other. Find the relation between p and q. Given polynomial p of x is equal to x square plus px plus q. Here a is equal to 1, b is equal to p and c is equal to q. Given zeros, the wording twice and thrice of each other is a bit unusual. Let one zero be 2 alpha. Let the other 0 be 3 alpha. Now let us use our relationship formula to connect p, q and alpha. First one, use the sum relationship so that sum of zeros is equal to alpha plus beta. Here alpha value is 2 alpha and beta value is 3 alpha. B is P and A is 1. So that 5 alpha is equal to minus P. Isolate alpha so that alpha value is equal to minus P upon 5. Make equation number 1. Second, use the product relationship so that product of zeros is equal to alpha into beta is equal to C upon A. Put the value of alpha, which is 2 alpha. Put the value of beta, which is 3 alpha. 2 alpha into 3 alpha becomes 6 alpha square. It's equal to the cube. Make it equation number 2. Find the relation. We need a relationship between P and Q. This means we must eliminate alpha. We can substitute the value of alpha from equation 1 into equation 2. Start with equation 2, which is cube is equal to 6 alpha square. Substitute alpha is equal to minus P upon 5. Then it becomes 6 into minus P upon 5 whole square is equal to cube. This implies 6 into P square upon 25 is equal to cube. Now multiply both sides 25. So here the outside 25 cancel the denominator 25. Then it's equal to 6p square is equal to 25 cube. This is the relationship between P and Q.